Hello and welcome. Today, let's look at how to find the total current through a simple electric circuit with two resistors in parallel. So we do have a simple electric circuit with two resistors, one of which is 2 ohms and then the other 3 ohms, and these two resistors are in parallel. However, we do have a potential difference of 6 volts across them. Let's look at how to solve this problem. So upon closing this key, what happens is that current is going to flow from the positive terminal, that is the terminal with the higher potential, to the terminal with the lower potential. Therefore, the current is going to run from the positive terminal, that is conventionally the direction of the current. So let's call this current I. Now, this I is the total current. However, since we have a junction here, according to Kirchhoff's law, this current is going to split into these two paths. So the first one is going to split into along this path I1. So let's call it current I1. And then the second part is going to go this way through the 2 ohm resistor. Let's call it I2. All right. However, since these two resistors are in parallel, it means that there is the same potential difference across each of them. So the potential difference across the 2 ohm resistor is going to be 6 volts, and as well as across the 3 ohm resistor is going to be 6 volts. So the voltage across each of them is going to be the same because they are in parallel. So this is all we need to know for this circuit. However, to solve the total current, there are two approaches, and I'm going to show you the simplest and the straightforward approach. But after solving this, and you know the second approach, you can comment that down below. We can have discussion about that. So to solve this circuit, we need to apply the Ohm's law. Ohm's law says that the potential difference, delta V, across this circuit is going to be the total current times the total resistance. Now, since we are looking for the total current, we can divide both sides of this equation by the resistance. So divided by R. So this R cancels this R to 1. And then we have 1 times I, which just gives us I, which is the total current, is equal to the potential difference, delta V, divided by R, which is the total resistance. So take note not to use just one of these resistor values. You have to use the equivalent resistance or the total resistance due to these two resistors in parallel. Now, when two resistors are in parallel, the total resistance is given by 1 over R equivalent is equal to 1 over R1 plus 1 over R2. Okay. If you have more resistors that are in parallel, such as let's say we have a third resistor, then it's going to be plus 1 over R3. Okay. If you have more, then plus all the way to 1 over Ri resistor. So that is how to determine the total resistance when two or more resistors are in parallel. Now, since we have I is equal to 2, what this means is that we have only 2 resistors. So we are going to have the total resistance to be 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So now from our circuit diagram, I labeled this I1. So definitely this 3 ohm resistor is our R1, and hence the 2 ohm resistor is going to be R2. So let's plug these values in. So we are going to have 1 over 3 ohms plus 1 over 2 ohms. So we end up with 1 over R equivalent, which is the total resistance due to the 2 resistors in parallel, is equal to 1 over 3 plus 1 over 2. Now this is a fraction, so we are adding 1/3 to 1/2. There are so many ways to go about this, but I will do the cross multiplication approach. So here we are going to have, I cross multiply 1 times 2, that is going to give us 2, and then plus 1 times 3, that is going to give us 3, and then I divide by the product of the denominators, right? So 3 times 2, which is going to be 6. We can further simplify this to 5 over 6. So what this means is that our 1 over R equivalent is equal to 5/6. So therefore, we can say R equivalent, or the total resistance due to these two resistors in parallel, is equal to 6/5 ohms. We can simplify this, and that is going to be R equivalent to be 1.2 ohms. So this gives us the total resistance due to these two resistors in parallel. The last time, remember, we did for when they are in series, the resistor values add up to give the total resistance. However, when they are in parallel, you can see that now we have a much lesser resistance. Okay, so now let's plug this in our Ohm's law equation. So now we are going to have our total current I is equal to the potential difference, delta V, which is 6 volts, and then divided by the total resistance, now which is 1.2 ohms. So if we divide 6 divided by 1.2, we are going to get 5, all right? And volts divided by ohms is going to give us amperes. So the total current through this circuit is going to be 5 amperes, and this would give us the final answer. Okay, I hope you enjoyed this video. If you found it helpful, please like, share, so that this will reach more high school and college level students. And also, if you are new to this channel, follow or subscribe, and I'll see you on the next one. Bye bye.